In December 2019, China notified the World Health Organization of several cases of human respiratory illness, a disease later named COVID-19. The virus causing this disease is known as severe acute respiratory syndrome coronavirus 2. The disease spreads through small droplets that are expelled from the nose or mouth when a person with COVID-19 coughs or exhales. Therefore, standing close to someone who is infected can put you at risk. These droplets can land on your hand and be transmitted through something as simple as a handshake, if afterwards you touch your eyes, nose, or mouth, the so-called T-zone. The virus is known to survive on different types of surfaces, so touching these contaminated surfaces and then touching your T-zone brings a high risk of infection. What we know so far: the coronavirus is spherical in shape, and its genetic material is encapsulated by different types of proteins. Some of the key structural ones are spike S protein, the most prominent feature of coronaviruses from where they get their name, then M, or membrane protein, and the so-called envelope protein.
Assalamu alaikum. I'm Nazmul Shahid and welcome to my online class. I am a lecturer in physics under the Department of Physics in Boyshall Cadet College. Today I discuss chapter number 6, that is geometrical optics. And the learning outcomes of today's class is, after end of today's class, you must be able to, number 1, explain principle of microscope. Number 2, explain principle of telescope. Point number 3, explain principle of reflection telescope. Number 4, and there is last one, explain refraction and dispersion of light in prism. So no more delay, I am going to discuss about first topics, that is microscopes, and there are 3 types of microscopes. There is the simple microscopes, and there is also one kind of simple microscope, or another name is compound microscopes, and this is also a compound microscope. Firstly, what is the definition of microscope? Microscope is an optical instrument used to viewing very small objects such as mineral samples or animals or plant cells, typically magnified several hundred times. There are 2 types of microscope. Earlier I said that there is simple microscope, there is magnifying glass, and this is the magnifying glass, and then number 2 is complex or compound microscopes. This is the last one. And what is the simple microscope? A magnification glass that is called hand lens, that's in laboratory context, is a convex lens that is used to produce a magnifying image of an object. And now I give the definition of compound microscope. A compound microscope is an optical instrument consisting to convex lens of short focal length, which is used for observing the highly magnified image of tiny objects. The compound microscope can magnify the image of a tiny objects up to 1000 times. In 1610, Galileo invented such microscope. And firstly, I discuss about the working principle of my simple microscope. And this is the image formation of simple microscopes, and this is the convex lens. And if the object is present in between of main focus, then its image is formed in the same side, because if we draw the ray diagram, these 2 rays never be meet real, but when back it must be meet in virtually. So this is a virtual image form, and this is the real ray diagram of simple microscope, and we know the lens equation, that is 1 by v plus 1 by u is equal to 1 by f, and here the image must be virtual, so we take the virtual image minus v, and now we put the values of minus v in the main equation, that is minus 1 by v plus 1 by u is equal to 1 by f. Now I multiply v in the both sides, so v by v plus v by u plus v by f, and finally we get that minus 1 plus v by u is equal to v by f, and finally we can write that v by u is equal to 1 plus v by f. And we know that the equation of magnification m is equal to minus v by u, and as the image of this situation is virtual, so put the negative values, we get that m is equal to v by u, and we know that the values of v by u 1 plus v by u, so put the value, and we get the magnification m is equal to 1 plus v by f. And if the clear image formation or of clear view of image, then the v is converted to d and v is same, because if v is the distance for clear viewer of image, then we convert it to d, then we can write the magnification formula m is equal to 1 plus d by f. So in simple microscope, the magnification equation m is equal to 1 plus d by f. Now I am going to discuss about compound microscopes. Earlier I said that there are two types of lens we used, and both of the lens is convex lens, and this is the ray diagrams, and we show here the principal focus the both sides, and we also see here this is the main focus, and if the object is outside of the main focus, then a real image is formed here, but the image formed, the that is the real image is formed, and it must be present in the main focus of the second lens, that is eyepiece lens. So the condition for formation of image formation in compound microscope, for object lens, the object must be stand outside of the main focus, and the image, the object of the image must be formed in the main focus, in between of main focus, then a virtual image must be formed. So this ray must never be meet again, so a virtual image is formed here, and this is the actual image formed in the compound microscope. So object size is AB, this is small, but the image size is too large, and this is also the virtual image. So you must be memorized that the object must be outside of the main focus of the object lens, and the eyepiece lens, the object must be present in the main focus in between. If the object present in between of the main focus, then the image must be virtual image, and it must be larger. So I discussed, and from the figure I next show you the main equation. So you also describe, this is the clear vision of d, there is d nothing but it's also v, and the length between two lens is l. So we discuss the main equation of compound microscopes, and for this reasons there are magnification formula, we take that m is equal to beta by alpha, and this is also very small, so we take m is equal to 10 beta by 10 alpha, and the length by the height, so m is equal to m double a double prime by b double prime by d into d by a double prime. Then we also convert it, m is equal to a prime double prime by d is equal to d by ab, and lastly we can write that m is equal to a double prime by ab, and lastly we also we can simplify it, m is equal to a double prime by ab prime into ab prime by ab, that is nothing but m into me, that is eye magnification and object magnification. So two magnification is called as like this equation. So ME is equal to virtual impedance, and it is as like simple magnification, that we can write that 1 minus VE by AP, or that is nothing but ME is equal to 1 plus D by AP. That's I show in the previous slide, that is simple microscope. And another one is M naught is equal to minus V by U. So if we put the main two types of magnification occurs, that in a component microscope, and put the values of this in the component microscope, we get the result M is equal to minus V naught by U naught into 1 plus D by AP. So this is the main equations, and you also convert it in another form. M is equal to minus L by F naught into 1 plus D by AP. So this is the equation for magnifications, and we everywhere we use this types of equation, we cannot use this types of equation. So the main equation of compound microscope, M is equal to minus V naught minus by U naught into 1 plus D by F. So here is a minus, this is a minus. And now we discuss about telescopes. The objects at a very far distance created very small virtual image in our eyes. To see these objects clearly from distance, we use a telescope. There are two types of telescopes. So one is refracting telescopes, and another is reflecting telescope. Diffracting telescope use of big apparatus, lens, and a long focal distance. There are three types of refracting telescopes. One is astro telescopes, satellite telescopes, and Galileo telescopes. Reflective telescopes use mirror and objects. There are three types of reflecting telescopes. These are one, Newton's telescopes, and Hertzscale's telescopes, and Georgian telescopes. So here we are going to discuss about astronomical telescopes. So this is a big convex lens, and this is a small convex lens, and the ray is coming from infinity and meet here, and the object is from here, and the image also be virtual, and the length between two foci between the lens is f naught, and this is also f, and this is length between the two focal points is L is equal to f0, that is object focus plus eye focus. And this is a considering angle, and from the equation we discuss in the next slide. So again, the magnification M is equal to beta by alpha, and this is very small, so we can write here again M is equal to, that is same as like compound microscope, but it is the opposite equation of compound microscopes. As like, we can write that M is equal to minus L minus AP into, that is by L minus L by F0, and we can write here M is equal to minus F0 by AP, that is object focus by image focus. And we can also show the equations in another ways, and this is the ray diagrams where we made, and this is also the virtual image is formed. So there is same as like equations that we discuss about. M is equal to beta by alpha, and same way we can write here. This is the same as like equations. M is equal to minus f0 by uv, and we know the length equation 1 by v minus 1 by u is equal to 1 by f, and 1 by minus d minus 1 by minus u e is equal to 1 by fe. So 1 by uv is equal to 1 by fe plus 1 by d, and we put the magnification equations, then we can write that total magnification equation M is equal to minus f0 by ap into 1 plus fe by d. So this is the total magnification equations in telescopes, and this is very simple equations. And here I also show you the telescopes of reflecting telescopes. There are two types of mirror, and this is eyes, and the ray is coming and reflected back in the eyes and goes through the mirror reflecting. And from the image formation animation, you must be clear about how the light comes from infinity and comes to the ice. So and is here the magnification m is equal to minus f ni. And now I say something about corona cautions. You must stay at home, avoid close contact to others, and avoid touching your face without wash your hands, and frequently you wash your hands. And now I discuss about prisms. Prism is a glass or other transparent objects in the form of a prism, especially on that the is triangle with refracting surface at an equal angle with each others, and that as apparatus with the white light into spectrum of colors. So this is prisms, and now we discuss about the refraction through a prism. This is the ray diagram of prisms, and here I see that, or you see that the ray is comes from OB, and that is OQ, and in the surface of uh, AB, and uh, it comes to inner part of the prisms, that is QR ray, and it goes again the RS path. And we know that in the outside of the prism there is a rare medium, and inside of the prism there is glass medium, there is a denser medium, and when it comes again it comes to rare medium. So light comes from rare medium, then denser medium, then goes again to rare mediums. So if we draw the incident point at a normal, then it is the incident angle, and again there is the refractive angles, and outside of the prism and goes again back or towards or make a distance from the normal, then it is also the incident angle, and there is also repetitive angle. So there are two incident angles and two repetitive angles, and if the we know that if the light rays comes to rare to rare, then it comes to the normal, and when the light rays denser to rare, then it go away from the normal. For this reasons, this kinds of occurrences happened, and this is called angle of deviations. So deviations is as like this. If you draw a ray, that is the refractive ray, and it back to the original ray, and make an angle, that is called deviation. So the light initial light goes this path, and after entering the prism it goes this path. So this is bending, and how much bending or how many angles is bending, that is called deviation. So our target is finding out the values of deviation angle phi. So for the point of incident angle, we already discussed that PQM is I1, and the repetitive angle is TQR is equal to R1, and R is the point of incident angle, and again we write that SRN is equal to I2, and R point, the repetitive angle is TRQ is equal to R2, and we know that the outer angle is must be the total of the sum of the inner angle. So phi is equal to RQU plus angle of QRU, and I is equal to, we know that that is RQU, this I1 is equal to, we know that the opposite angle is must be same. So this angle and this angle must be same. So I1 is equal to angle of RQU plus R1. So RQU is equal to I1 minus R1. In the same way, I2 is equal to angle of QRU plus R2. Then QRU is equal to I2 minus R2. Now we put the values in the main equation. So phi is equal to I1 minus R1 plus I2 minus R2. Now we simplify this equation. Phi is equal to I1 plus I2 minus R1 plus R2. And we know that this angle and this angle must be 180. This is the opposite angle. So we can write here T is equal to 180 minus A1, and the triangle of this we can write that T plus these two angles, sum of two angles is 180. Then T T is equal to 180 minus R1 plus R2, then we can write here A angle is equal to R1 plus R2 from these two equations. And if we put the main equation, phi is equal to I1 plus I2 minus A. And now I show you the minimum deviations. For minimum deviations, if we increase the angle of incident angle, then we show that the deviation angle is also be decrease. And after some points, that is the after one point of incident angle, again the deviation is increase. At which angles the deviation is minimum, that condition is called minimum deviation angles. And we also know that at minimum deviation angles, that is I is equal to E and R1 R2 is equal to R. This is also same. This is called minimum deviation, and we know that A is equal to R1 plus R2, then A is equal to twice R, because both are same. So R is equal to A by 2, and we also know that I plus E is equal to A plus phi in the main equation. So 2I, there's both the I also be same, and both are also be same in minimum deviation. So 2I is equal to A plus delta A. So I is equal to A plus phi delta m by 2, that is minimum deviation. And we know from Snell's law, mu is equal to I1 sine of I1 by R1, that is the I by R. Then we can write that mu is equal to sine of I, that is A plus del plus by 2, and A is sine of A by 2. This is the refractive index in prism, and this is find out only for the condition of minimum deviations. Now I discuss the dispersion of white light through prism. In 1666, Newton noticed that when sunlight goes through prism, the projection on a skin creates beautiful formation of light. So white light is not just a simple color, it's a composite color. So after diffraction of prism, the rays is divided into primary colors. It is called dispersion of light, and the formation is called a spectrum. So dispersion is the separation of white light into colors of any radiations according to wavelengths. A spectrum is the band of colors observed as a result of dispersion. Now I discuss some knowledge based questions. Number 1, what is compound of a microscope? Number 2, what is a compound telescope? Number 3, what is meant by diffractive telescope? Number 4, what is the difference between compound microscope and telescope? Number 5, what happens when a red light passes through a prism? Now some comprehension based questions. A, who uses compound microscope? Number B, can a telescope can be used as a microscope? Number C, how is dispersion related to refraction? And now some MCQ questions. 1, the refractive index of an unilateral triangle prism is V2, and what will be its angle of minimum deviation? That is 1 option 30 degree, B option 36 degree, C option 45 degree, and D option 60 degree. Number B, the expression for the magnification of component microscope is 1 option M is equal to -1 and -1. B option, that is -1 plus
there is something, and third option -1 is 1 plus. And which of the following is correct? There is B 1 and 3, 1 and 2, and D 1, 2, and 3. And now the chance for homework. For normal vision, the distance between the lenses of an astronomical telescope having magnification 4 is 0.4 meter. An object is placed at 80 centimeter in front of objective of the telescope. Question number A, define focal length. Question number B, what do you mean by optical center? Question number C, calculate the focal length of the eyepiece. And last number D, find the nature and magnification of the objective from the above. Now question and answer sessions. If you have any questions and query, then ask me after the finishing today's lesson. I will reply you in dashboard. And lastly, I show you a video clip for clear information of today's lecture. And again, I said you please stay at your home to reduce the risks of COVID-19. And with this hope, I, Nazma Shahid, conclude of today's lesson. Thank you all.
Simple microscope. A microscope is a device which is used to view very small objects that cannot be seen with the naked eye. There are many types of microscopes, such as simple microscope, compound microscope, electron microscope, etc. A simple microscope uses the principle of a magnifying lens or reading glass. A simple microscope consists of a convex lens of short focal length mounted on a plastic or metal holder as shown here. Principle and working of a simple microscope. When an object is placed between the principal focus and the optical center of a convex lens, a virtual, erect and magnified image is formed. The ray diagram given here explains how an object looks enlarged when viewed through a biconvex lens. Observe that the object and the image are on the same side of the lens. Image is formed at the least distance of distinct vision from the eye. That is, the distance from the object is approximately equal to 25 centimeters. Magnifying power. The magnifying power m of a simple microscope is given by the relation m is equal to d by f, where d is the least distance of distinct vision and f is the focal length of the lens. From this equation, it is obvious that to increase the magnifying power of a simple microscope or magnifying glass, the focal length of the convex lens should be made as small as possible. Therefore, a convex lens of shorter focal length is used as magnifying glass, that is, shorter the focal length, larger the magnifying power. However, the maximum magnifying power a convex lens can have is about 5. Watch repairers use convex lenses for viewing very small parts of the watches. Click on the link provided to view the derivation. Compound microscope. A compound microscope is an instrument designed to obtain a highly magnified image of a small object. A compound microscope consists of objective lens, eyepiece, and a microscope tube. The objective lens of a compound microscope is a convex lens of very short focal length, FO. The object to be viewed is kept very close to the objective lens. The eyepiece of a compound microscope is also a convex lens of short focal length, FE. The focal length of the eyepiece is slightly greater than that of the objective lens. In the microscopic tube, the objective lens and the eyepiece are mounted coaxially at the ends of two tubes, which can be made to slide into each other so that the distance between the two lenses can be adjusted. The ray diagram gives the principle of a compound microscope. The object is mounted on the stand below the microscope tube. The objective lens forms a real, inverted and magnified image A-B- of the object. The image A-B- acts as an object for the eyepiece. The position of the eyepiece is so adjusted that the image lies within the focus of the eyepiece, FE. The eyepiece acts like a magnifying glass and forms a virtual, erect and magnified image of the object. The magnifying power of a compound microscope is defined as the ratio of the size of the final image as seen through the microscope to the size of the object as seen with the naked eye.
Telescope. A telescope is an optical instrument used for viewing distant objects. Telescopes are of two types, namely, reflecting telescope and astronomical telescope. Click on the links provided. Astronomical telescope. An astronomical telescope is used to view celestial bodies. The main parts of the astronomical telescope are objective lens, eyepiece, and telescope tube. Objective lens is a convex lens of large focal length and large aperture. The eyepiece is a convex lens of short focal length. Telescope tube has a set of two coaxially mounted brass tubes where one tube can easily slide into the other. The objective lens and the eyepiece are fixed at the ends of the telescope tube. The distance between the objective and the eyepiece can be adjusted with a rack and pinion arrangement. This adjustment of the telescope is known as normal adjustment. Let us now understand the principle of a telescope with the help of a ray diagram. The rays of light coming from a distant object are parallel to each other. This parallel beam of light is focused by the objective in a focal plane and is perpendicular to its axis. The image P', Q' is formed at FO. The eyepiece is adjusted so that the image P', Q' lies in its focal plane. The rays of light after striking the lens of the eyepiece emerge parallel, and the final image P" and Q" is formed at infinity. Magnifying power of an astronomical telescope may be defined as the ratio of the angle subtended at the eye by the image to the angle subtended at the eye by the object. Magnifying power in terms of the focal length is M is equal to FO by FE, where FO is the focal length of the objective lens and FE is the focal length of the eyepiece. When theta is small and is measured in radians, theta will be equal to tan theta. Thus, magnifying power M is equal to tan of angle P' D q dash divided by tan of angle P dash C q dash. From triangle P dash Q dash D, tan of angle P dash D Q dash is equal to P dash Q dash by P dash D. And from triangle P dash C Q dash, tan of angle P dash C Q dash is equal to P dash Q dash by P dash C. M is equal to P dash Q dash by P dash D into P dash C by P dash Q dash. That is equal to P dash C by P dash D. P dash C is the focal length of the objective FO. P dash D is the focal length of the eyepiece FE. Thus, M is equal to FO by FE. Reflecting telescope. Reflecting telescope is also known as Newtonian type of telescope as it was first designed by Sir Isaac Newton. In the reflecting telescope, the objective is replaced by a parabolic concave mirror. Shown here is a reflecting telescope. A reflecting telescope is used to view objects such as planets, the moon, star clusters, galaxies, nebulae, and multiple star systems. Let us now understand the principle of a telescope with the help of a ray diagram. Incoming light rays pass down the barrel of the telescope and are reflected by a parabolic mirror at the base. These rays converging towards a point A as shown in the figure are made to fall on a small flat plane mirror. The mirror reflects the light towards an opening on the side of the tube that passes into the eyepiece. Note that in a reflecting telescope, chromatic aberration is eliminated as the light does not pass through glass except the small eyepiece.